Okay, so one of the three rules you learn in C3, chain rule, product rule, quotient rule, here's the product rule for differentiating products. So a product is where you've got two things multiplied together, two functions of x. So you wouldn't bother using the product rule for differentiating something like 3x, even though that is a product, because 3 isn't a function of x. You can use the product rule if you like, but you'd be massively overcomplicating it. Obviously, this is just 3. So it's for differentiating a product where both of the two things that are being multiplied are functions of x. So I'll call them f and g. So we're going to be differentiating f of x multiplied by g of x, like that. And the product rule says that the derivative is f of x is going to wait while g of x gets differentiated. And then they take turns. It's all very nice and civilised. They just take turns. So now g of x is going to wait while f of x gets differentiated. Isn't that nice? And I'm just, in this video, just telling you the rule because you don't actually need to understand or know the proof of it. But I have made another video in which I prove this. So for those of you who are proper mathematicians who don't like a rule without a proof, you go watch that video and see. In this video, we'll just practice using it. Okay, so let's do an example. Let's do something nice and simple. Let's do d by dx of x squared x cubed plus 4. So here is my f, that's x squared, and that's just going to nicely wait while this one gets differentiated, g. So you can do it in either order, doesn't matter which is which. So that's 3x squared plus nothing. There we go. Then we've got a plus, and now we've got g is waiting now. He's had his turn. He can just wait. And now it's the turn of the f to get differentiated. There we go. Let's see if we can tidy it up a bit. 3x to the 4, add 2x to the 4, add 4, add 4, no, add 8x even, which is 5x to the 4, add 8x. Suppose we could pull out that x if we really wanted to. 5x cubed plus 8. There we go, done. Let's do another example. Okay, something a little bit more tricky. Let's do the derivative of x to the 4 plus x times sine x. Okay, for those of you that don't know, the derivative of sine x is cos x, and that's in your list of formulae to learn. And again, you don't need to know the proof, but there is a separate video to prove that the derivative of sine x is cos x if you're interested. Okay, so I'm just going to use that now. So which one should we have waiting first? I might have, well, sine x can wait, that's fine. Sine x, you can wait while this one gets differentiated, and then plus, and then you can wait while it's sine x's turn. Ta-da! Done. I mean, can we tidy that up? No, I don't think so, not particularly. Let's just leave it like that. Okay, last one. Mega challenge. Not really. This is quite an easy rule. Sine x cos x. Whoa, a triple product. Okay, so basically it's not a triple product, is it? It's a double product, like, because it's that times that. So let's just do our normal rule. I'll tell you what, we'll do it the easy way first. So let's have sine x cos x waiting while x squared plus 1 gets differentiated, and then we'll put plus, and then x squared plus 1 can wait because it's had its turn while let's think about this separately, while we differentiate sine x cos x. But because I can't do that in my head, I'm just going to write that down and then think about what's going on here. Well, actually, this is another product, sine x times cos x. So this equals 2x sine x cos x plus x squared plus 1, that's just waiting. Now we're differentiating sine x cos x using the product rule. So the sine x can wait while I differentiate the cos x. The derivative of cos x is minus sine x. Again, go to that video if you don't know that, but it doesn't matter. Basically, the derivative of cos x is minus sine x. Then plus, and then the cos x can wait while I differentiate the sine x, which gives me cos x. And so tidying it up a little bit, sine x cos x plus x squared plus 1. I'll write it this way round. Cos squared x minus sine squared x. And I tell you what, if we're being really clever here, yeah, let's do it. So in terms of the product rule, I'm done, finished. I've differentiated it. But it's fun playing with things, isn't it? So let's have a play. So you might not know your trig formula yet. So if you don't, go and learn them. So instead of writing 2x sine x cos x, I'm going to write x 2 sine x cos x. If you've learnt your formula, you'll be going, oh yeah, I see. X squared plus 1. Cos squared x minus sine squared x you should recognise. Cos 2x. Cos 2x is cos squared x minus sine squared x. Or, actually, cos 2x is 2 cos squared x minus 1, or 1 minus 2 sine squared x. You could have any of them. And this bit, the reason I wrote it like that is because 2 sine x cos x is 2 sine x plus x squared plus 1. Look how nice that is. See how important it is to learn your trig formulae? Yeah, that's all. I think that's enough examples. I'll write out the formula once more to help you remember it. So, to differentiate f of x times g of x, you first of all do nothing to f and differentiate g, and then you do nothing to g while you differentiate f. Doesn't matter which way round. The other way you might sometimes see it written or see me refer to it is basically, I'm really lazy and I can't be bothered to say of x, g of x, f of x, g of x, f prime of x. So sometimes I just say u and v, meaning the two things that are times together, and then I hold the u still and differentiate the v, and now I'm super lazy because I don't even write dv by dx. I just write dv. How lazy is that? That's proper lazy. So there's me holding still one function. U is waiting while I differentiate v, and then plus, and then v waits, v is waiting while I differentiate u. I shouldn't really write like that. du, I should write du by dx. But this is like the lazy way of writing it out. The derivative of uv is u dv plus v du. Either way round.